lecture from Solford, and this is what I've been looking forward to very much for the week. He is Professor of Neurosurgery at Lund University in Sweden, various other professorships. And I think all those who are sceptical about this area will, ought to hear this lecture. It's electromagnetic fields comes in all shapes and sizes, and I think it's going to talk about low frequencies and radio frequencies. Probably more important, radio frequencies modulated at low frequencies, which is a very important experimental thing. I must say I'm envious of him, of all the things that he's able to do, and I'm not able to do. We're all very grateful to what you are doing, and all your colleagues in Sweden. Over to you.
Thank you very much for those. Thank you very much for those kind words, really. And it's such a pleasure to be here. I'm really grateful to you, Masatoshi, for having organized it and made it possible. I'm happy to be able to tell a little bit about what we are doing back home in Lund. And I'm trying also to see what happens around the world, even if this is such a large field, the electromagnetic field, that you can't cover everything in 45 minutes, yes. So this means that how did this life that we talk about start? And that we heard so much these days that passed. It's been a great pleasure to listen to all those clever guys who really know what it is about. I'm not a physicist, I'm a medical doctor, but I'm doing my very best, and I'm trying to give you some little parts also of our philosophy when it comes to physics. The Big Bang and what came after there, we know this, that it's not so long ago. It's about 5 billion years ago that the sun was formed. And it is about 4.5 that Earth was formed. We heard that the other days. And the first life signs were seen 3 billion years ago, about. And then you can read yourself if you want. You know all these developments up till the very last seconds of the existence of the Earth, where we have come those human beings that now sit here today. We also heard in these days about the geomagnetic field and the magnetic storms. We live in a very special situation where we should be so happy that we have our magnetic shielding from all that is passing from the sun towards us with the solar wind. To be able to survive here, we do have to have the shielding. Mars hasn't, might have had, and we might lose it. So we should be very grateful that we have one. According to what I've read, it's even a little bit decreasing in later years, so we never know what's happened. We know also that we live in all these cycles, the Earth's rotation, the Earth's rotation around the Moon's rotation, the Sun's own rotation around its own axis. So there are many different frequencies of days here which might be influencing upon our life. We are shielded from what comes from out there by the ionosphere, which is a very, very, very important part of our life. Here it looks as if it were far away from the Earth. That's not true. However, it shows how it really shields us off from what is coming from out there. We know that we have an atmosphere, for sure. It's not very high. It goes up 160 kilometers up in the air, and then you're in the thermosphere, where it starts to get hot again, to my surprise. And also, you know about these fields now, these ionospheres, where the D region is only 60 or 80 kilometers above the surface of the Earth. And then you have two more regions, E and F, that they all help to filter away what comes from out there, especially from the sun. So, as you can see here, the D layer is here, what's called the mesosphere, and so much of what is coming from outside is stopped before it reaches the surface of the Earth down here. And you can see the external ultraviolet is gone, the X-rays shielded, the other types of ultraviolet shielded, and finally the visible light, of course, reaches us, and so does also the infrared. But that's what really comes through. Very little comes through there for the rest. And here you can see that visible light that we talked about, and also the infrareds, while the microwaves lying down here are not passing through this ionosphere. The ionosphere, if you think of it, is very, very thin. Most pictures we see, it looks as it did a little while ago, but the truth you have here in front of you. The radius of the Earth is only 4,600 kilometers. It's almost nothing. And the ionosphere is even less. It's 80 kilometers. is 8 millimeters as compared to half a meter. In reality, that's nothing. That's where we live. That's where we have to be careful about what we have to breathe and to survive. Nature itself has organized it so that we do have some normally occurring vibrations here on the Earth. There's the Schumann vibrations. They are made by the strong lightnings on one half of the around the Earth, sometimes south, north in the rest of the year, and they supply us with, funnily enough, these vibrations that do have the same frequencies as our EEG happens to have. They are about 7.8 Hertz as a major frequency, while they also have sub-harmonies and also higher harmonies. But as you can see here, the area where they are most pronounced are exactly where we have the alpha waves of our brains, also the beta waves, and also the theta waves. So might be there is some sort of a correspondence between them. I haven't found the scientific description, but it's been told that the cosmonauts from Russia, they were smartest. They were first out with bringing little vibrator up in their rockets in the first moments in order to get a little bit normalization of the life out there. The Americans took it over. I have not found the real source for that information, but I've been told that it was might be make something very good. The geomagnetic field does make things to us for sure. It helps the birds. It's also, if you take it away, as you can do in that Faraday's cage, there will be no field reaching you. You can see decreases of vital functions in bacteria. You can see it in the stem cells of the plants, the meristem cells of roots are involved in that and are influenced by that. And also you can see cell proliferation and other things being influenced by having a non-geomagnetic field available. The magnetic storms, they cause additional biological dysfunction. That has been shown. And also, we do less well. There are more road accidents. And there was a very major, strong solar wind in September '84, where it was shown both in animals and in human beings that we were desynchronized, as it was told. And also, there were problems with the cardiovascular systems of patients. So it seems that things happen because of what comes from out there, but not at that major level might be. So life exists in a very, very thin and frail sphere around Earth. That is really something that, while I thought of this lecture, I have been really realizing myself. So since the birth of Earth, we have had very little low-frequency electromagnetic fields, these elves. We have the Schumann vibrations, but basically nothing else. Then we have all these guys, Volta, who started in 1800, and then Tesla, we heard of him, and the Morse, and the Marconi, and the Bell, and the Edison, all of them supplied us with lots of ELF, the extremely low-frequency fields surrounding our world, inside the ionosphere. And even worse, 5 billion years ago, or 4, those of you who know better can tell, we got our ionosphere, and there were basically no microwaves on the Earth. And what has happened? The first time ever was when Sir Robert Watson-Watt found out to make the radar. And a few years later, this was in the late 30s, a few years later, another gentleman, Percy Spencer, sat working with a radar machine and felt that the candy bar in his pocket started to melt, and so you had a microwave oven, utilizing these microwaves. So we started to get microwaves 60 years ago, and today we have an abundance of them. We are filling our space with this. The very first machine from the Ericssons in Sweden, 1956, you can see here, this is a so-called mobile phone, if you are a very strong person. And here you have it today, small and handy, and you have all these base stations. And we do everything here to fill our little ionosphere with all these microwaves. Does that make a difference, or does it not? Well, today 1/3 of the world's population are volunteering as guinea pigs in the world's largest biological experiment. It's never happened before, that 1/3 of the world's population takes the machine that's emitting strong microwaves straight into the most nice organ you own, your brain. I think my brain is my most nice organ. And in any case, that's something we should remind ourselves of when we talk about these things. So, we have been happy enough to have this as a sidetrack in my research in Lund since almost 20 years, It started with the paper by Shivers et al., who showed that the MRI examinations of rats in London, Ontario, opened up the blood-brain barrier for the albumin of the rats themselves. I went there, visited them in 1988, and then started the research, because I thought, as a neurosurgeon, and a neurosurgeon interested in brain tumor treatment, that it would be possible to utilize these electromagnetic fields to open the blood-brain barrier, to let cytotoxins come out to all the bad cells from the brain tumors, which thereby should be killed and cured. It didn't work that way. But I understood that these fields really make a difference to our brains, because we repeated what Shivers had done in London, Ontario, and continued by separating the fields, especially studying the radio frequency field. And that we are continuing with. And as you can see, we have done so many experiments by now, at the 950 megahertz carrying wave, and also with many different modulations. And we have studied the leakage of albumin, but also through the BBB, but also neuronal damage, gene expression, cognitive functions, and we continue. Basically without funding nowadays, because nobody funds it anymore, but we continue because we think it's so very important things. Many of you know that the capillaries of the brain are different from those out in the body. The capillaries out in the body, they allow easily things to pass over the endothelial wall, the cells that constitute the vascularity there. While in the brain it's different. You have, this is a simplified model, but still, you have these cells that make the capillaries of the brain, they have tight junctions. They're tightly attached to each other, side by side in this way, making lumen, where this albumin and all the other constituents of the blood are passing. And then around you have these end feet of the astrocytes, the glia of the brain, is surrounding here, and also communicate with what happens. It's a whole little world of activities here. There's also two basal membranes, which are not depicted in the picture. So all this together is a whole little world of its own. And there we have a barrier that things in the blood that should not in the brain, they shall stay in the blood. And if they start to leak into the brain, something is wrong. This is our equipment, which we have used since the very earliest days. It's a so-called TEM cell. It's where the electromagnetic field is exerting its effects upon the rats, and half of the rats are kept in machines where there is no mobile phone or no electromagnetic field coupled, and the others are then exposed. And it looked a little bit crowded, but the rats like them. Rats like small rooms. They jump back. If we have a full day experiment, they go out for luncheon, and when they're coming back, they jump in with pleasure. So they do thrive in these small boxes. Now these are experimental setting with 4 of them at a time. So we have a long series of animals in the past, more than 1,600, which have been published in 1992 until 1997. And they have been exposed, most of them, for 2 hours, others a little bit shorter or a little longer. And they have all been examined within 30 minutes after the exposure, most of them, and some others were allowed to survive for 16 hours in those materials. This is a section through, a coronal section through a normal rat brain, or a rat brain that has been not exposed, but been a sham exposed animal. You can see in the hypothalamus of that rat, there is a leakage of albumin. There is an uptake of albumin down here, which it should be. So this is an internal control of our study. And you can also see that there is some little leakage up here at the ventricles, which is also normally occurring. So some albumin in the brain is okay, in the right places. And there might occur one point in a normal brain or in a control animal, which also has a leakage, without being of any major pathology. But here you can see this is an animal that has been for 2 hours in a GSM telephone situation with a very low energy, only 1,000 of what you have at the antenna of the mobile phone. It's a very low energy that makes the difference here. And that's the most astonishing thing, that the lower the energy, more or less, the worse the effect. And that I will show you some later picture. Here's another situation, very little in the brainstem, but a lot out in the cortex, as you can see. And this is a close-up. Here you have the small capillaries, and you can see around them there's a leakage of albumin out into the tissue surrounding the vessels, quite far away from the vessels themselves. And this is the albumin that's leaked out, the rat's own albumin, studied by anti-rat rabbit serum. You know this little setup, and we measure how much energy goes in and how much comes out, and we know how much goes into the little creature. So far, all our experiments have been at non-thermal energy levels. We don't heat the animals. It's always under 2 watt per kilo, which means that that's the limits set by the official institutions around the world. Many of them have gone further down, being cautious. Others have not. So hereby we have a situation where we shall know that all I show you are at values which are below those which are the borders of the institutions. I think there is a biological window. This is what Ross Aidy has said. Somewhere around 1/1000th and 1/10 of a thousandth of the energy at the antenna. That's where the most pronounced effects in our small rats when they are exposed to these values. This is a complicated picture. It shows you, however, that when you have 2 SAR, the SAR value, a specific absorption ratio of 2 watts per kilo and even above, then you have rather little effect at 16, 50, 217, and also continuous wave modulation here. While when you go down in the levels here you have 0.1, start to happen things. There are 91 animals and there are controls at the 50 Hertz. There are 217. At the 217 Hertz you have the 56 animals with their controls, and they are highly significant. When you go further down, it's a little bit a spread picture. So it's not until you go down to what I talked about a while ago, the 1/1000th or 1/10 of a thousandth, that you really have the major effects here. And that's true for 4 Hertz, 8 Hertz, 16 Hertz, 50 Hertz, and 217 Hertz. And the large materials are in the 50 and 217 Hertz groups. And this is the situation. We don't know why it is like that, but other people have seen it. And that was seen so by Oscar and Hawkins in 1977 with microwaves of the type of ovens which they studied in those days. And it has values as those I talk about, that they also have this inverse U where they tell that something happens with the passage through the blood-brain barrier. So it's not an original new finding. Other people have seen it too. It was a major meeting at this castle in Germany a few years ago, where we were all asked to come to stand up for what we were saying, and the idea was to find what was wrong in our experiments. They thought it must be wrong. It was a huge group of German physicists who invited us, and the mobile industry. And we were 3 days locked into the castle, and we came out alive, and we showed what we had found, and Professor Obineau from Bordeaux showed what he had found by use of fluorescent material. It was very much the same, and the verdict by the super judge, who was Dr. David Begley from King's College in London, was it seemed clear that the RF fields can have some effects on tissues. But it's difficult to convince the surrounding on these things. So it's not no good to have albumin in the brain parenchyma. It happens to be so that my colleague, the professor of urology, now emerita, Barbara Johansson, has shown with her Dr. Rees, as you can see here, that intracarotid infusion of hyperosmolar solutions in rats gives an albumin leakage and also neuronal degeneration by that. Stroke-prone hypertensive rats, the same. In acute hypertension by aortic compression in rats, the same. Neuronal damage and albumin leakage. And at epileptic seizures, we also have an extravasation of plasma. And there are, might be because of the hypoxia, I don't know, but there are also damage to the cerebellar Purkinje cells. And others say that it's the most likely neurotoxin in serum. And if you inject albumin into the brain, which has been done by Norwegian scientists in 1994, presented, then you can see that you damage the blood-brain barrier by having the albumin around the vessels, and they start to leak, and there will be more albumin, and thereby you have a damage in those brains, as was presented there. So that's the background. And what about passive mobile exposure? Yes, it's 185 meters away from the antenna if you have a base station where a rat leaks most albumin through his or her blood-brain barrier. It's far away from the base station. The human being should be closer, I guess, to have values comparable because of the bigger brain, the more bone, the more whatsoever covering. But still, it's not so that it's absolutely harmful, at least for rats. I just talked about rats. I just studied rats. Let me think now, I was a little wrong. This 1.85 meters from the, of course, from the mobile phone, sorry. 1.85 meters from the mobile phone antenna. While from the base station, those rats have the problems 190 meters away from a base station if you are in the cone where those waves are moving. So that's our findings. And what happens then when you put this mobile phone with 1 watt per kilo at the antenna? Yes, you can see those values that are most efficient in opening the blood-brain barrier in rats, that's in the middle of the brain. This is the basic ganglia. That's where your Parkinsonismus sits. And, well, I don't know if it makes a difference to people, but I made the calculations. And those values that we have learned are not very good for the blood-brain barrier. They exist in there. That's been shown by many other people, Gandhi in America, among others. So this made us think, does it make harm to the neurons if you expose animals? So we did a rather small experiment, that could be said, but we have repeated things later. And that was published in 2003. And we had, as you see, 0.002 watts, that 2 milliwatts per kilo, 20 milliwatts per kilo, and 200 milliwatts per kilo in 8 animals in each group and 8 controls. And they were allowed to survive for 50 days, which is quite a long period. And to our extreme surprise, we found that in hippocampus, we had this situation, with a lot of, up to 2% of the neurons being shrunken, looking like this. And according to our pathologists, they call it the dark neurons. It's a rather debated type of damage, but it's looked upon as nothing else than dying or dead neurons in this area. And the bad thing is also in the cortex, out here, we also see them. And that is an abnormal picture because when you compare to the 8 control animals, there was one with a modest amount of that type of cells in his or her brain, while out of those 8 with a low energy, there were 4 out of anything, 2, moderate, more. And with those higher degrees here, we had more of it. So there was a significant difference between the 8 animals here and the 8 there, the 8 here, but not the 8 here. So this is not exactly the same picture as for the albumin leakage situation. You will see it's that more energy, more effect. But it's a small material, I have to repeat that. But that was 50 days afterwards, so we were very astonished. And it was published in the Environmental Health Perspectives, and I will come back to that. The fact was that it became very significant. Though it was such a small material, and one control animal with a moderate amount of these dark neurons, still a highly significant value. And we said the following: the intense use of mobile phones by youngsters is a serious memento, and neuronal damage of the kind here described may not have immediately demonstrable consequences, even if repeated. It may, however, in the long run, result in a reduced brain reserve capacity that might be unveiled by other later neuronal disease, or even wear and tear of aging. So we couldn't exclude that after some decades of often daily use, a whole generation of users may suffer negative effects, maybe already in their middle age. That was tough to say, and that was really printed by NIH journal, and we were a little bit happy about having told the world these things as we're seeing. But we also went back to the laboratory in order to see how we could continue this work. So instead of 50 days, we now studied 48 rats after 40 days, and 28 days, 48 rats. Half of them controls, half of them are exposed. And here you have the exact numbers. The shams, 8 in every group, and here that's the old 50 animals. So let us just concentrate upon these 14 and 28 days. As many males as females. Now we have 0.2 milliwatt per kilo, and then the old values again. So we've really gone far down. That's 1/10 of the thousands as we talked about. Even if it's a large material of animals, in each group it's not so many as you can see, but together it's almost 100 animals. So this is the result. We remember that after 50 days we had a highly significant value for the dark neurons. We also have a clearly significant value after 28 days of these dark neurons in the brain. Why we don't see them after 40 days? It's very peculiar. I don't know what happens. We have studied after 50 days if it was apoptosis, according to what we heard here from Dr. Nishinomiya. And it is not apoptosis, so we don't know what it is. Looking for the neuronal albumin, yes, after 40 days, lots of albumin inside the neurons. You can see here, in the neurons, in the cytoplasm, lots of neuronal albumin. While the albumin foci that we saw in the beginning here, clearly seen after 40 days, but not after 28. So I don't have easy answers to why this happens, but it does happen, that's the problem. So we also continued with a long-term exposure. with 56 male and female fish of 344 rats, which we have exposed to GSM, mobile phones, straightforward, 100 milliwatt per kilo and 1 milliwatt per kilo. And we have allowed them to survive after two hours in the temp cells once a week for more than a year. And then we have checked for their behavioral tests, but also for their perfusions, fixed brains. We've also spared, if some of you in the group, I know that Dr. Ishino and Dr. Hondu, I think this is interesting, we have spared in formaldehyde testes and in -80, testes, ovary, kidney, spleen, liver, bone marrow, blood, in order to make collaborations with people around the world. We are checking for the different markers for brain aging in these old brains now, and that were exposed every week. Gliosis, pigments in urine, synaptic functionality, and also apoptosis, which I already meant to you, that we did not find after 50 days. What might be interesting is for the behavioral test, the episodic memory test, which was mentioned also here the other day, with a recollection of a unique past experience in terms of what has happened, was checked in these animals. And here is the test setting. The animals are allowed to first train twice and learn about how we move things around, and then they have to look around after, I think it's 56 minutes, and seek for the objects which they have seen before versus those that not seen before. And the interesting thing, we get a significant difference between those animals that were treated, exposed, versus the shams. While I have to say that those animals that stayed as cage controls down in the cellars during the same time, they had even worse. So that is very much in line with what we learned a little while ago, that if you train, if you start as a young little rat and train by traveling every week, you have a nice trip with a very caring, nice girl taking care of you, putting you into cages, being kind to you, petting you, and then you travel back. If you just sit in a temp cell without GSM, you have a value of 2. If you sit in that temp cell with a mobile phone for 2 hours a week, you have a figure 1. So you have just half as good memory for the episodic memory test as those that were just traveling. While if you sat in the cages, you have just 0.4, even worse than those that were mobile phoning while they were traveling. And only 1/5 of those that were traveling, not mobile phoning. So there are some facts that we see here. So, what happens with gene expression? And that is shown by others, for sure, that things happen in vitro. Other people have done in vitro studies, as you can see here, Pacini, Lee, Raimondi, and many others. And they do see that 1 hour with GSM phone makes significant effects on mitogenic signal transduction and apoptosis genes upregulated. They've shown that 221 genes altered after 2 hours, 759 after 7 hours, apoptosis-related upper cell cycle genes downregulated. Next group here, a reflex group, it's a big group. Out of the 6 cell lines, they found that 3 had altered gene expressions for ribosomal proteins. So others continue. Lechinsky is well known in these circles. He has checked with human endothelial cell line, and he has shown also that there are effects, altered phosphorylation in the heat shock proteins. And Chow, 2006, also up and down regulated. So we went into the real world and checked in living animals. So together with Leif, we worked in our temp cells. He was in Stockholm, and he checked what happened in cerebellum at 400 milliwatts per kilo treatment of these animals. And we ourselves have checked what happened in cortex and hippocampus in a recent material with only 25 milliwatts per kilo. And the Belayev work, which is published, showed that there were significant facts. 11 genes were upregulated, not much, 134 to 274 found only, but at significant levels. And that is a first step to try to see what happens in vivo. And we have done, as I said, the same with our animals with a lower value of 25 milliwatts per kilo for 6 hours. And it's quite a lot of things that happens, and it's at highly significant values. So in hippocampus, the extracellular region, these are now groups of genes. We should remember that. There's not one by one. There are groups of genes hanging together in clusters according to these systems that we are utilizing. And thereby we get significances with 23 zeros, which sounds too good to be true. But the fact is that these systems of genes that are influenced by our treatment of 6 hours and animals directly thereafter killed, they come up with values which are highly significant, according to my biostatisticians. And it's the same ones. So if in cortex you find these, you find the same in 6 cases in the hippocampus, and the vice versa. The 10 most outspoken in the hippocampal ones, many of them are also seen in the cortical situation. So it's a large number of these who are related in some other way to the albumin transport through the cerebral endothelium. So we think that we have one coupling here between real facts, these genes, and what we have seen about the leakage. Other people, Lennart Hardell, Kjell Hansson Mill, Kundi, the 2 first Swedes, they have made a report together with a large group of researchers last summer. By initiative report it's called. It's a little bit tinted because it wants just to show the risks of everything. They're really trying to tell it's not free from risks, so they're a little bit proactive in that way. But in any way, it has been shown that 10 years of use of mobile phones, that's not only one study, that's repeating. You have more of the highly malignant gliomas, the worst cases of them all. That's what I'm really interested in as a neurosurgeon, to try to cure. You have a higher incidence of them after 10 years use of mobile phone. And also the benign type of tumor, the acoustic glioma. So these are situations where now more than one study has shown that it seems to happen something with your genes or wherever it happens now. So we have to be a little bit cautious about it. And also very lately, that's this year, recently, came an information about how EEG is definitively influenced by the mobile phone emission. There is effects which are repeated and which are proven by just using a mobile phone, which shifts in our EEG. Mechanism behind it. Rossetti was one of the great guys in the field, neurologist, California, made major contributions. And he thought a lot about why, and why could we have this peculiar situation with a window effect, where lower energies have more effect than the higher ones. We have proven the same things in our lab. And he said that the oscillating field might result in changes of the membrane potential. We went into this. We have tried to sort this out ourselves, and I think we are the only one in the world who really managed to go with an external field onto biology, having small organelles, small vesicles from spinach, which we fill with radioactive calcium. And by giving it the right energy, this is ELF now, the right energy from outside and the right frequency, according to Blanchard, who made all these calculations for it, we can really show that the suitable combinations, they directly interact with the calcium channel protein in the cell membrane. And we could see by this model, we just buy them on the marketplace, spinach, take the cells out, turn them outside in, and then see how we can influence the calcium flux over the channels. And they follow exactly the prescribed pattern of the Blanchard mathematics for how you should be able to influence life. I'm a little bit proud of this, and nobody has really minded about it. I think we are the only in the world who made it. There's nobody ever who asks us for it and are impressed by it, so I'm a little disturbed by that. Other people have been very clever, and that's again the London Ontario group. These wonderful people whom we met. It's a wonderful group of mixed people like you here today. They are physicists, and they are doctors, medical doctors, and they are dentists, and they are zoologists, and zoophysiologists, and all sorts of people. And they were there already in 1988 when we met them. This wonderful group of different minds. And they continued, they started then working in snakes, the land snake, Cepea nemoralis, as you can see there. And they were checking pain already in those days. And they have collected all their knowledge in a paper published only days ago by a lady called Del Sepia, and that includes other guys of the group, Cavaliers and Ossinkop. They were there 20 years ago. And as a conclusion of a large paper based on more than 50 studies, most of their own, mostly in this land snake, but also in mice and rats, that has shown that the effects on pain, nociception, opiate-mediated analgesia, constitute one of the most reproducible and reliable effects of EMFs with observed increase in pain threshold. The fact that EMFs increase pain perception is of particular interest if one considers our ubiquitous exposure to various EMFs and the prevalence of pain problems in our society. They're writing this paper. Might be people have so much pain these days because of electromagnetic fields that we have everywhere. Might be true, and these are very serious people. And they've worked with it for 20 years or longer, 25. Very serious people. And here comes something into picture which I would like now to enlighten my friends here in physics. And you might tell me that I might be totally wrong, but I'm going to tell you something which I think is interesting. The physiological mechanisms involved in what's happened require definition, and the world doesn't know yet. It happened to be so that a gentleman born in England via Switzerland came to Lund in 1907. His name is Charles Ernest Overton, and he was the professor of pharmacology in Lund, and he was remembered when I studied medicine in Lund as a very special man. And he might have given us a basis for a new theory. The mayor, that was the other guy, Mayor and Overton together, said that all these anesthetics that we have available 100 years ago, how on earth can they work? They all work according to their solubility in olive oil. So they're all directly possible to place like that. It might be so that the effects of anesthesia could have and help in our world. It's a new theory. Might be so. It's not the Hodgkin-Huxley that is the guys whom we should obey when we try to understand what happens in these membranes. Might be so that soliton propagation in biomembranes and nerves are the answer. I was so intrigued when I started to organize myself for this lecture that I found that over a little sound, just over Öresund, half an hour from my university, is the University of Copenhagen. There is a Niels Bohr Institute, the great Niels Bohr, contemporary and friend of our major host here this time, Yukawa. And that means that they say that the thermodynamics of general anesthesia, in a paper came out just recently, that anesthetics lower the temperature at which lipids become solid, making it difficult for the wave to form, thereby preventing nerves from sending pain signals. They have a new theory, a new physical theory about why anesthesia works, because Hodgkin and Huxley has never worked as an explanation. Nobody has ever understood how it could work. And so, a little bit earlier, the same guys, Heimberg and Jackson, it's a German gentleman and I think he's an American, they together have made on soliton propagation in biomembranes and nerves. And it's so challenging, it's so nice, and maybe this is a little key for the future understanding of what we are talking about, the effects of electromagnetic fields upon us. Well, this is to go too far, but this is an illustration from their paper from 2005, and that shows those solitons. That might be too much in detail, and the next picture might be easier. It was a gentleman, John Scott Russell, who made canals in England, and he found that when a boat drove in the canal, there was a peculiar wave. One single wave. That's why he called it a solid term, the only wave. It's moving like that, moves in the canal. You can go out and look yourself if you like. And that has been evolved then into lots of clever physicists making these peculiar things. How it happens in the wall of a nerve, for example. It could happen in the axons walls. That's what the two guys in Copenhagen think. I met them and they are very convincing. So this might be a tool to start thinking in new routes. And now the question here is, what is life? Is life DNA? I dare say might be so. There are in reality facts that people have looked on this, where they've thought of the DNA being an antenna receptor for the microwaves, because the length of it is so well applicable for these electromagnetic fields. So the people have said it long ago. There was a paper by Sweekor. Those of you who work in this field know that Sweekor now works for Motorola very hard, but he was already in 1984 saying that resonant microwave absorption in selected DNA molecules in a soliton model could possibly be the direct effect from fields upon that. And there are other papers, Englander and others, who have said the same thing. It might be so that it is a soliton effect happening in the DNA when the open state in long polynucleotide double helices is active. Was it first or second? First, fantastic. I never used to be so rapid. Thank you very much, Emma. We'll have a slow clock. In any case, so this transcription bubble which we talk about here, might be so that the influence of what we are doing really happens here. And this has been around for 20 years in the world, this knowledge and this thinking, but it's not been exploited by some reasons. And here is a guy called Prohofsky, whom I have found out, in 1988, made his contributions about these ways that things happen in the walls of both the neurons, for example, all sorts of, it might be the endothelial cells as well, and also in the DNA situation. So now we are just approaching the very end of this. It has been said by a gentleman, Zhang, I was in China 40 days ago, and I tried to see him. I happened to be in Tianjin, and I couldn't get hold of him, but I have shifted some mail with him. And he said already in 87, soliton excitations in deoxyribonucleic acid, double helices. And he's been continuing on that path. And there are existent resonant absorptive microwave energy for both longitudinal and torsional nodes in the RNA. Resonant frequencies for the former and the latter are in the region of gigahertz and sub-tetrahertz. And remember that the modern mobile phones, they're 1800 or 1.8 gigahertz. 1.8 gigahertz. Might be so. It's almost too good to be true or too bad to be true. I don't know what I should say. And this is not dead. There is a Russian gentleman, Golo, who wrote about these things only recently. So there is a knowledge in this field which might be explored by us if we are just smart enough to know how to handle it. So, the mammalian brain in man-made EMFs, solitones, the solution to the question of its effects. Question mark, might be there should be more question marks. But we would like to put this in the hands of our smart physicists who might make something great of it. And finally, the question was, what is life? I would turn it into, what will life be on Earth? When we have filled our thin sphere with microwaves, there is the sphere. That's where we live. And all other possible adverse effects that we have heard earlier today. Well, this is meant to be the power, the only power we have is our brains. And this is the network we have in our brains. These are the neurons connecting each other in that fantastic inner universe. Might be the way that our inner universe might save our outer universe. And there should come something up. Yes, oh yes. I would like to say this again. Our generation has an imperative obligation to further investigate the links between EMF and biology in order to prevent possible detrimental effects of its own intention of the microwave emitters. So that's my little message to you. And then there is a final little message which is not meant for the tape, but for our host especially. Masatoshi, this is a piece of art. This is a mixture of artists and all sorts of people. And it influenced me last night to go back home and make a little piece of art for you, as to remember these fantastic things you have done for us. And as you can see, it's again the brain from inside, it's the earth, it's everything around. It's the great guy here, and here he is again. And there are some great guys in my lab with whom we have done all these experiments. But that's the end. Thank you very much.
Question?
I'm interested in initially how did you notice or feel the cause of EMF is responsible?
I found, what you say, how I first found out?
Yeah.
Oh, that was really not our idea. That was these fantastic people in London, Ontario. They made a publication, Shivers et al., in 1987. And they told that when they, in the nights, sneaked time in the new MR machine standing in the hospital, sneaked the rats into the machine when no patients were there, for 32 minutes, that's the time in those days it took to make did I say MRI? I hope I said MRI, into an MRI machine. And there they found out that they opened up the blood-brain barrier. And there's the components of the electromagnetic field there. It's a static magnetic field, an magnetic field, and also the radio frequency field. We went back to Lund and separated them, and did the same as they had done in London. So I found the same things, but then we found the radio frequency was the most efficient blood-brain barrier open. So we concentrated in the future upon that. So since then, we have worked only with that. But for those experiments which I mentioned to you, with the extremely low frequency fields for the passage of calcium over the membranes. For the rest, it's with the underland fields and the radio frequency. We start with 4, 8, 16, and 50. 50 in the walls, the frequencies, but were asked by the telephone industry in Sweden, by the Ericssons, to include 217, which would be the new GSM in the early 90s. So that's how we choose it. And so it's something that came. My interest was to see if I could use it in my clinical neurosurgical activity to cure myelitis, getting hold of the migrating cells. It didn't work that way. But I couldn't stop doing this because we have seen something. I have a responsibility to continue to seek out what it is. I never say that it's dangerous for human beings. I don't know. I don't know. But I could say that it's not so good for rats. And the blood-brain barrier of the human being and the rat is the same anatomically, exactly the same anatomically. But I know there are some differences on the enzymes. There are some enzymes that differ between rat and man. And that might be that gives us some sort of defense. I have been speaking of those silly machines since 1982. I was the first neurosurgeon to have a so-called mobile phone. I carried it 4.5 kilos, but I carried it around. So I have done that to my brain for so many years. Before I started to understand might be it's not all that good. Might be. So most of us believe that we are in a healthy state, though we have utilized our mobile phones for so long. But might be in the long run. Thanks.
Yes, I have two questions. One, I thought your graphs showed something as a function of the modulation frequency. You use amplitude modulated high frequency, is that correct?
Yes, we do.
How can that be affected by, how can the effect be affected by the rate with which you vary the amplitude?
That's what we really thought should be the crucial thing. We thought in the beginning that calcium was very important. There are lots of studies by Blackman and everybody that show that calcium is influenced, and that's a little bit why we did it in our vesicles. But we thought that 16 should be some very crucial situation, 16 hertz. We were told by other people that that's where you should start. So that's why we made it 16, and we made it 8, the half harmony and the quarter harmony, and then we said 50. Nice, it's in the walls, might be nice, it's close to 48, so we took it. But the major information is really not that those frequency modulations makes a difference. It's the 915 megahertz continuous wave and modulated. They all have the same effect. There are small differences, yes, but it's not the modulation.
No, I wouldn't expect that there would be any effect of modulation, actually, as a matter of fact. The other question is different. You showed that both glioblastoma and vestibular schwannoma had higher frequency. These are two very different tumors, of course, you know better than anybody. And of course, both are genetic, but they are genetic
totally. I fully agree. I had to short things down here, but the fact is that I am so astonished about those findings. I'm really astonished, because it's the same guy who managed to find first the one thing and then the other thing. It is Hardell in Örebro, in the middle of Sweden, professor of oncology. And I couldn't believe it when he came up with this acoustic neurinomas firstly, and it was rather small materials and a little bit too much sensitive, so to say, or he really felt there's something here. But it's been redone. It's been done, among others, by myself, being contributing with patients to a major study in all of Europe. And it comes out the same thing. More than 10 years of use increases the risk for the acoustic neurinomas. So that is rather solid facts now that it happens. But it's not a major problem. In Sweden, might we have 200 a year in Sweden. Now we have 280 a year. Small difference. Not yet so much to be seen, but still significant. When it comes to the gliomas, I could have spent a little bit longer on that. The only one who really has shown that significantly is the same Hardell. He has large materials, but it's not been proven in the second study somewhere. So that is not so hard facts. That's again more than 10 years, which of course could be true. You start to make these alterations in your setup, in your gene aberrations and mutations, and it could happen that way.
Somewhat more interesting for glioma, because you die from those, but you don't die from...
That's right. Thanks to the clever neurosurgeons, you get rid of the vestibular schwannomas, right? But that's really that's what I'm really trying to do, to cure a glioma before I die. And that's damn difficult. So I have to live for very long. Yes, eat less.
You said very clearly, and I understand that you don't know why you obtained that inverse U curve, inverted U curve, less energy giving more damage. But you must have thought about this a lot over the years. And in your dream of dreams, what sorts of things might you think about tentatively? And in particular, can you think of any precedents in other physical, chemical, or biochemical systems?
Oh, there are many of them. Arsenic, for example. If you take too much, you die. If you take an appropriate amount, you do much better. That's used as one. There are books filled with chemicals which have these windows, where they're beneficial in proportion, in some doses, and they're very unbeneficial in others. So, in chemistry, there are lots of examples. There is not so much to compare with here, but what was said was Rossetti, who started to think of these things in 1960. Great guy, I met him several times, a neurologist, very thoughtful. He had a rather simple-minded way to tell it. I asked him the same question, what do you think? You have thought about this for 40 years. He said, well, if you scream in a person's ear, he won't hear what you say. If you whisper too lowly, he won't hear what you say. If you speak in a right frequency, the right amplitude, he will get your message. Might be too simplified. But there is, as this is biology, these are membranes that live their own life. If they have these solitons working there, which is a passage of, I don't understand it quite well, but they say you are so close to this melting temperature of the lipid layer, B layer of your cell exome membrane. So if that holds true, it works all the time with its own small frequencies, all sorts of frequencies. Not calcium, not potassium, and not sodium running out and in. I do think they do run out and in, but might be these new ideas working in a different way makes the difference. If so, it could be easy for our waves tuning into what happens in the DNA situation, tuning in with the right frequency and the right amplitude, and also in the membranes, where much of what I have seen happens. That means the leakage of the albumin. Maybe you correspond with a frequency of a membrane or of cells which is fitting with what happens to be the somewhat lower energies. Not easy answer, but attempt to an answer. Have you any ideas? You have thought a lot, and you are very neurophysiological.
I wish I did have an idea.
Can I give you an idea?
Yes, you have an idea. Lovely,
Yes.
Mr. Chairman.
Well, I mean, it's a very simple idea.
Yes. Not too simple.
If you take a magnetic field, there's a thing called cyclotron resonance, yeah? And that's going to cause the calcium and sodium ions to vibrate at different frequencies. And so some of those frequencies would be natural to the body, and others won't be natural. Well, the Earth's magnetic field produces resonances between about 30 and 60 hertz. And, well, you will change the physiology when you change that field. So I didn't see any difficulty about windows.
Oh, thank you. Okay. Thank you. You're the first person who ever said it. Thank you.
Yes.
Your silicon idea, very interesting for me. Your silicon idea.
Yes.
Your silicon.
Oh, it's not mine. It's not mine.
But, okay.
Borrow.
Yeah, okay. But my question is that in order to excite one silicon, we have some threshold energy. Otherwise, the excited wave is the amplitude of the excited wave is so small that it may be dispersed and decay. Therefore, you require some threshold energy, okay? Some critical value of energy.
Critical energy.
Yes. And so we have to excite the end of the medium by some stimulus, exchange some critical value. Always such a kind of excitation is always expected.
I feel that's all the questions, because, as I told you, I learned about the soliton theory only 2 months ago. I had no idea about solitons before that, so I'm so happy to bring it to you, but I'm here to criticize. So my answer to you is I will go back to my physicists. I do have physicists and radiophysicists who are very, very helpful. And we are thinking of these things, but we will include people who do better than we. So the 2 guys in Denmark, we went over and said hello to them. So I met these 2 nice people whom I talked about. And they are very enthusiastic about this. So they and we will pass the bridge over between Sweden and Denmark and continue the talks and make experiments. So I can't answer your question, but I will do my very best to go back home and try to find out. Thank you.
On the threshold effect, when you look at the work of Robert Becker and electrical effects on salamanders, for example, it's clear that in certain kinds of electrical magnetic fields enhance healing, and other kinds of electromagnetic fields impede healing. And maybe the work on what fields are healthy or harmful in the healing wounds and this kind of thing would have some relevance to brain cell deterioration.
Well, I can't. Yes, it's quite possible. All these treatments are with ELFs, the extremely low frequency fields, for the salamanders and also orthopedic surgeons. There's no question about it that orthopedic surgeons say yes, all of them. That yes, it helps to heal faster. There is an effect upon the osteoclasts.
But only in certain ranges.
Oh yes, you have the special weights, but I don't know exactly what they have, but it's really proved that that works. So there is a chance to influence with the elves upon biology. Yes, 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 yes. But maybe we can learn something from it. True.
What has been the reaction of the mobile phone industry to your findings?
Do I have to answer?
Yes, please.
Well, it's not as bad as it might sound. To be honest, in the beginning, it was the researcher at the Lund University, Mäktigtaler, who was the developer of the mobile phone in Sweden, who came to us and said, why don't you make 217 also, just for the fun of it, and let us see what happens. And that's why we started doing so, so we helped him with that. But then when the Stockholm office of Ericsson heard that there was some peculiar work between his subordinates in Lund, and some very odd people who thought there could be some problems with it, they stopped it immediately. So, but we have intellectually continued our talks with people, local people from Ericsson, nice, clever people. But when it comes to other companies, I don't name any others, because the others have not been so friendly, but they haven't been very unfriendly. But when we publish things and try to get them published, they have a huge staff of people who try to find something wrong in the papers. And I also had people from one company said, we will help you. Oh, you get no funding. We come and help you. That was from far away. It was not a Swedish company. And they sent a spy, a professor from a university, and spied on us on 3 days. And we showed everything. And then he went back home, and then we said to the company, we haven't heard from you. What happened? Oh, we have no money. We are so poor, so we can't help you. And then we understood that he had been as a spy to see whether we may find something wrong. But we don't think that we do anything wrong. We show what we do. And we don't try to make too much out of it. We see it, I'm annoyed by it, and I would like to tell the world that I see it, but I don't scream. I don't rush to the papers and say, please come and make an interview. Never. We try to make it scientific. But as I said, it can be somewhat difficult sometimes to get papers published. And the poor guy, the wonderful, nice man, Obino, who just did what we did, he has never managed to publish his paper. So it's not so easy. And so one has to be strong. And you have to have another platform. And I'm happy to be a very seriously surgical researcher in immunology for brain gliomas. Thereby, I can do these things as a little hobby. Either they would say I was a crook, working with these peculiar things, a mesmerism guy. That's what they do. So one has to be a little bit careful. But if you have a strong platform to stand on, you can allow yourself to do these things. And I think I have a mission in trying to continue. Thanks.
Well, thank you very much.
Thank you very much.
I mean, we wish you very all the best in your real pioneering work. Thank you.
I should say that it's been a pleasure to be here with John, because he really knows about these things and he really takes a major interest in it. So we'll continue our discussions as well. Thank you so much.